here at Microsoft. And I grew up just west of Sydney, about an hour in Australia, in a beautiful location called the Blue Mountains. And I grew up with sort of sustainability and environmental sort of custodianship my whole life. And becoming a software engineer over the last few years, I've been heavily involved in building software to sort of solve and to protect and preserve and to heal, the environment and projects around that space. And then in the last few years, I've been looking at how I could have impact in how people build software in a sustainable manner. And that's what brought me to the GSF, and that's why I became part of the GS and became involved with the Green Software Foundation. But first off, welcome to the Green Software Foundation Global Summit for 2022 in Redmond, hosted here at the Reactor. It's pretty significant. It's a bit of a milestone. GSF has been around for just over a year, and a lot has happened in that time. And I'm going to give you a whirlwind tour. There's a lot of stuff to get through, a lot of content to get through today. We've got some activities and a couple of workshops to do as well. So I'm going to kick off, and it's great to see everyone here in the room, and it's great to also see everyone online. If you've got any questions, pop them in the chat. We've got some people here that can filter them through to me as well. So what is the Green Software Foundation? So when we think about the Green Software Foundation, it's a non-profit, aiming to build trusted ecosystem of people, standards, practices, tooling around building green software. And, we have a manifesto, we have a mission, and the vision, I'll read this because I don't want to misquote, is to change the culture of building software across the tech industry so sustainability becomes a core priority of software teams. Just as important as performance, security, costs, and accessibility. So all those other sort of non-functional components that we think about, why aren't we thinking about sustainability in the same way for engineers, right? And so it's really important to us to be thinking about, sustainability is a core piece of building software, not just an afterthought.
I'm okay. I'm saying this because...
So who are we? We're 25 member organizations. The best thing about the Green Software Foundation is it's growing fast. So these slides you may even find are already out of date. We've got 559 individuals that are participating in the Green Software Foundation at the moment from all over the world. So not just here in the US, all across Europe, across Asia. There's a lot of participation around the world. So let's talk about what is green software and what it means to be part of the climate solution around green software. So two broad ways of looking at software as part of the climate problem and as part of the climate solution. I was talking before about how I was involved in climate solution projects before. But green software is really about looking at software as the problem. How can we reduce the impact that the software we build has on the environment? We want software to be part of the climate solution, but there's no point doing that if we're creating a problem at the same time that sort of outweighs that or is unmeasurable or unsustainable at the same time. And so what we want to do as part of the Green Software Foundation is really focus on how can we be looking at software, how can we look at the teams that are building software, the culture around software, and how we can reduce the carbon emissions of software. And I'll talk a little bit about why we think about it in terms of carbon in a bit. So what are we doing within the Green Software Foundation? So we have a lot of projects and we have advocacy. This today obviously is a conversation around advocacy, but we currently have 11 approved projects. I chair the Carbon Aware SDK project. I'm happy to talk about that after today if anyone wants to come and have a chat with me, but we don't have enough time to talk about it right now. We have a few projects in the pipeline. We have 60 articles and interviews that we have that are posted. They're posted across 5 languages. So we have people that are doing translation. And when you think about, is there somewhere that you could participate within the Green Software Foundation? For some people, they're looking at where they can participate. They don't see themselves as software engineers. There are so many roles within the work that we're doing, and we need people that have the skills that can help us. The Green Software Foundation approach, we focus on the entire life cycle. And some of the examples of the projects, we sort of have this, this internal specification, which we call the Software Carbon Index. It's a specification for calculating sort of the carbon intensity of a piece of software. So when you build a piece of software, how can you measure that in a way that because you're measuring it, you can start to then measure it again and see if you can reduce the carbon emissions of a piece of software. We have external, so SCI open data. So can we create an open data set that people have access to that can help them understand, all the different sources of data to help you go and calculate the carbon emissions, the carbon intensity of the piece of software or the software systems that you were building. Because if everyone has to do it from scratch, it becomes too hard and then people sort of avoid it. How do we make it as easy as possible to people to get access to data so that they can calculate the carbon intensity of their software? And then you've got the Carbon Aware SDK, Software Development Kit. That's the project that I chair, just a quick plug. How do you understand and how do you get access to the data that lets you know the energy from the grid that you're pulling on? How intense is that from a carbon perspective? But also, how can we build an SDK and APIs around and a tool set around helping you build software that can make better carbon decisions, such as use energy when the sun's shining and the wind's blowing and you can use greener energy and things like that. What's the Global Summit here intending to do? What's the intention of being here today? So one is, a celebration of the partnership that's in place, the people that are part. Some of those partners are here today that I know of. But it's also, we want to make sure that we're talking to new people and making sure that you understand that you can have a role to play and partnership with us as well. And the other thing that we really want to make sure that we're doing, and this is something that the GSF provides, but how can we also bring people together to realize that there's a lot of like-minded people that really want to address this and not sure where to start or really curious or passionate, and they're all the right things to be. So if you want to learn more, you can head to the Green Software Foundation website. There's heaps of information there. There's buckets of information, all the projects, how to join, all that sort of stuff. We'll talk about more of that stuff through today. But the next thing I'm going to talk about just quickly is I'm going to go through some of the green software principles. Just bring up the deck. Let's go. So let's talk through the principles of green software. So when we talk about the principle of green software, what we're saying is, what are the things you should be thinking about when you're thinking about green software? What are some of the aspects you should be thinking about? And if you're not looking at all of these, you probably are missing something that's helping you make your software green. So the principles of green software were created in 2019, published online, and they exist to help you understand the actions a software engineer can take, or a custodian of a piece of software, for that matter, to reduce the carbon emissions of that piece of software. And when we talk about carbon emissions, we're talking about CO2 equivalent emissions. There are different ways to look at how emissions are created, but 1 ton of, for example, of greenhouse gases, if it's gas emissions, is equivalent to about 25 tons of carbon emissions. So we always talk about this in terms of CO2 equivalent because it gives us a single number to look at. The principles can be found online at principles.green. They're also on the Foundation website as well. They're worth checking out and they're worth sort of really understanding and thinking about. And they are evolving. They have evolved since 2019 as we think about the problem and the problem domain. And that evolution is something that's really come out of the GSS as we have these conversations. We go, hang on, something's missing here. Because if you follow all of these and you're not doing this, you probably still won't reduce your emissions. So when we think about greenhouse gases, the greenhouse gas protocol sort of defines scope 1, 2, and 3 emissions. I'm going to go through them very quickly. Scope 1 is the direct emissions. They're the emissions that you're creating yourself through the activities that you're doing. If your company itself is a factory, you would have emissions. The energy that you're consuming within your company, that's your scope 1 emissions. Scope 2 is your indirect emissions from electricity purchases, the things that you're consuming, the things that you're using that they themselves have emissions. Then scope 3 is your sort of downstream or upstream emissions. So byproducts of the things that you've created or are consuming. Green software really sort of focuses more around that scope 1 and 2 emissions, and that's sort of represented here with the magic triangle here. But it's very much about how do we measure across the board how the software that you're creating is creating emissions, right? Not only the emissions that you're consuming yourself, but the emissions that your software creates when you go and publish it or give it to 1 million people. So the 8 principles of green software can sort of be broken down into the following. Number 1, which is sort of an overarching one, is carbon or carbon efficiency. How can you build applications that are carbon efficient and reduce the CO2 equivalent that they create. The second one is around energy efficiency or electricity efficiency. So build applications that are energy efficient. By building applications that use less energy directly, you'll produce less carbon. The next one is to build applications that are carbon aware or think about carbon intensity. A really good example is if you could run a job later in the day where the energy is greener, then it would create less emissions. Similarly, you could run it in a different location where the energy is greener. You know, if there's a lot of solar in the energy where you're running it now, if the sun goes down, it's probably not going to be anywhere near as green. Can you run it somewhere else at that point in time? So thinking about the energy consuming. Number 4 is embodied carbon. So that's really about hardware efficiency, especially when you start thinking about, you know, mobile phones and the fact that a new piece of software gets released and you can't use it, you've got to upgrade your mobile phone. The carbon put into the atmosphere to create that mobile phone is huge. And if people have to upgrade to a new mobile phone, that means that you're actually, your influence carbon that you're creating indirectly by forcing people to upgrade devices is actually creating a lot of carbon. And it's over time, if the device is getting replaced every year, your yearly carbon emissions are going up. We can talk about energy proportionality. So when you think about, if you've got a heap of servers that are running at 30%, just having those servers on or having those systems on creates a lot of carbon. Can you actually be running them at higher percentages? Running them at higher percentages is a lot more efficient from a carbon perspective. It's a very complex topic because it's not necessarily linear, but having underutilized resources, having a cold standby, having a failover data center for those that work in that space that, you know, is always on and ready to go, but it might never actually need to be ready to go. And you're just consuming all this carbon by just having those things there sitting there. Networking is another area that we look at. I was talking before about maybe relocating workloads to another location to go and do it in a greener place. But if that means you have to send so much data across, you're creating a lot of carbon by sending all that data across. So how are you thinking about your networking in a smart way, using sort of like mechanisms and tactics to reduce that network load? Are you being smart about when you're sending traffic over a network? Demand shaping. So similar to sort of the carbon intensity. Sorry, I was sort of talking about these two at the same time. Demand shaping, you know, having your application use the grid where it's under less demand. And the last one, which is the one that we've added, is measurement and optimization. Doing all these things without actually measuring and understanding whether the optimizations you're making are actually having an effect is super, super critical. And so there are heaps of techniques on how to do this, right? But there isn't a single way to do all of this. And so, you know, today we're not going to be talking about, hey, this is how you can exactly calculate how much carbon your application is consuming, because there are lots of ways to look at that. But the way to measure it's with the SCI, and that's something that we're going to be looking at in a very short time. But these 8 sort of principles are the things that we think about when we think about what are the different ways that we can make applications more carbon efficient. Awesome. So we are running pretty much on time. So we're going to actually go on to the next section, which is talking about the Software Carbon Index, which is the standard that we've built out of the Green Software Foundation. It was published, first release was last year around about October. And it's what we're using to drive the conversation around creating green software. Bring up the presentation. Okay, so through this section, we will be doing a workshop. We'll probably break out into groups of around about 4 or 5 people. So start having to think about, look around the room, look at the people left and right of you, and obviously on the call, think about the people that you might group up with. And we're running a little bit ahead of schedule, but I'm sort of trying to do that because I'd rather be spending a lot of time in the workshop than listening to me sort of talk in depth about each slide. So let's talk about the software carbon intensity specification. So the software carbon intensity specification looks like this. And it can look a bit tricky, and some people find it a little bit overwhelming when they first look at it. But really what it's about is, if we sort of go down the bottom, is how much carbon are you producing per R? And when we think about R is it per customer? It could be per request. It could be per item delivered off a factory line. That's up to the person that's assessing their business. Generally, R is the thing that relates to how your business scales. So, you know, sometimes it might be a time unit, right? It might be per year, but that might not make any sense for other pieces of software. And so that's why per R is not defined. And so when we think about what it is, we look at, you've got the, if you look at E times R plus M, and I'll explain what everything is in a second. E is the energy that's being consumed, and I is the carbon intensity of the energy that's being provided. So the energy that's being consumed by the carbon intensity of the grid will give you the carbon that's being created while it's running, which we call the operational emissions, which would be represented by O on the next line. M is the embodied emissions. So the embodied emissions are in that hardware. If that hardware is being replaced once per year, and that R is per year, then that needs to be calculated, right? It might be every 10 years, it might be, but you need to understand the embodied carbon that's in that piece of hardware, because it cannot be ignored. And some pieces of equipment will cost more carbon to produce than they ever will consume or produce. So once you produce that item, the amount of carbon it took to produce that item for many items, including mobile phones, they're very unlikely ever to produce that much from the energy they consume, right? Think about a Raspberry Pi, something like that, right? You have 1,000 Raspberry Pis, that's a lot of carbon that's being produced. And so we look at operational emissions plus the embodied emissions per R, right? And as I said, you can't ignore M. For some things, M will be a very small portion of the emissions, and for some things, M might be a very large portion of the emissions, especially if you're selling software on a piece of hardware that people deploy somewhere and it's a small device. So, and then we end up with this SCI is carbon per R, but we usually talk about the top formula because this is the formula that everyone's trying to calculate. And we're not asking you to calculate that, but it's how do you think about the software carbon index, or the amount of carbon your software creates per R. That's the concept to really think about. Now, how can we use SCI? So because we can sort of write or use our software, and then we measure the carbon index of that piece of software, and then we can take some action because we want to reduce. All we want to do is reduce that number. We reduce it by 50%, we should have reduced the carbon that we're producing by 50%. And so energy efficient, you know, can we do things to make, you know, use less electricity? Now, making software more efficient from a performance perspective is a way to do that, but it's not always directly correlating. Sometimes you can do performance enhancements that consume more energy. I won't go into that, but there's things to just think about. Just because it runs faster doesn't mean it's necessarily using less energy. Hardware efficiency. So especially when you're thinking about M in that formula, if you can reduce the hardware, it could be more hardware efficient, you can reduce your SCI. And the last one is carbon awareness. Can you run your software at different times of the day? Can you run it in different locations around the world where the energy is greener and make better use of green energy? So when we think about energy efficient actions, the actions that are taken, one of the things that, you know, we're really looking at the moment within the GSF, and something that's really important, is like how do we profile that software? How do we understand the carbon, the consumption of that software? But if we can measure the current usage, and there might be different ways to measure it, it might be 80% of a computer for 12 hours. We know how much that computer itself consumes. We can sort of reverse engineer it that way. Or there might be other tactics to go and calculate the energy consumption of a piece of software. But it's really important that, you know, we're measuring that in a standard way and in a way that encompasses as much as possible. You know, there's no point going too granular and you're missing all these things around the periphery. You really want to be encompassing everything. And if you're encompassing a bit too much, that's actually better than not enough, right? You don't want to be in a situation where you think you've solved energy efficiency problem, but you're actually sort of greenwashing the information. And then you want to go and improve it. So again, put in the instrumentation, measure it, and improve it. You know, anybody that's done performance enhancements on any piece of software, even from a scalability perspective or a throughput perspective, this is no different. How can we look at it from a sustainability perspective and improve the numbers that we get out of that? And the number that we should be calculating out of that is the SCI. The other thing that we're sort of looking at is so that's talking about code. The other thing to look at is then also look at infrastructure, and just to do it in a very similar manner. So document the current infrastructure and look at your current architecture and infrastructure. Identify overhead, a lot of redundancy. I see a lot of the time there's a lot of redundancy where it doesn't need to be. Oh, we've got this just in case there's a problem. You know, when has there been a problem? Never. Okay. So, you know, do you have another backup site? Yeah. So there's redundancy within redundancy within redundancy, and it's not really needed. Sometimes it can be things like backups that are just happening way too often. They actually don't need to happen at that regular basis. You know, and that storage of those backups is creating carbon. There's so many different aspects to this. Sometimes people have, you know, really complex load balancing systems and infrastructure where something simple could actually easily do the job, and they don't need to have that complex architecture. You know, people that have worked in engineering software know that, you know, and we're guilty of it ourselves. I know I am, of over-engineering systems. When you think about that from a cost perspective, it doesn't really necessarily make sense. But when you start thinking about a sustainability perspective, you really start thinking, hang on, we need to go fix that, right? Because maybe the cost, people might be thinking that's someone else's money, but sustainability, it's your planet and it's everyone else's planet, right? So it's a really good way and a really good motivator to think about how you can improve that. And then you sort of right-size the infrastructure. But sometimes this can be, you know, creating, you know, just some efficiencies in the infrastructure and looking at how certain things are happening. And sometimes that can just be the operations across your infrastructure. So there's just so many different ways to look at it. Like, there's not just one way to look at it. There's holistically, do we have too much? We're running two pieces of software and two identical pieces of infrastructure. Could we be running them side by side? Are there things that we could be doing? Have we oversized our infrastructure because we've gone, hey, our peak users are going to be this, but we've never got that, you know, our peak load is going to be really high. We've never, ever built systems. We built the system for 10 million users, but we've only ever had 500,000 users. We're never going to have 10 million users. Hang on, maybe we should reduce the scale of our system. And so that's what we mean by right sizing, but sometimes it can just be about creating efficiencies in the architecture. So talking through that, and if people got lots of questions, we're about to go into a workshop, and you're more than welcome to reach out to me if you've got some questions about different bits and pieces. But we are going to go into a workshop. We're going to break out into groups of 3 to 6 people. Probably 4 to 5 is a nice number, but don't worry if there's only. We don't want to have too big a group because, you know, you will have time limits to sort of talk through things as a group and things like that. You'll run out of time if your group's too big. So actually, smaller does work well. We're sort of going to do a bit of a design-led thinking, sort of, or a design-led workshop. By that, we mean we're going to start with some very broad phrases that we're going to be going through. And then what we're going to do is we're going to sort of get together in groups, vote on those, and then start thinking about things that you might take as actions to reduce your SCI. So not to calculate it, but let's say you had a number. What are some of the steps that you could be taking and thinking about in your business that would help reduce the SCI? It's going to be 30 minutes. We do have a little bit of extra time, which is good. And we've got facilitators here around the room to guide you. And for those people that are online, if you've got questions, please put them in the chat and we'll make sure that we get to you as well. So the first thing we're going to do once we get together is these are the sort of statement starters. And so the aim here is, as a group, you're going to vote on one of these where you're going to think about this is the topic that you're going to be talking about as a group. And then I'm going to give you some more tips as we go. But the first thing to do is for everyone to sort of group up into groups of 3 or 4 people, starting now.
Awesome. Anybody have any questions? Otherwise, we'll start breaking out into our groups here. We're working on that now. And then, we can also reach out in the main room to ask any questions to Vaughn or Tammy as well. Give us just a minute to do those breakouts. Is this anyone's first time hearing about this methodology? Trying to index how much carbon's produced from a piece of software? Cool. That's exciting. I saw a stat earlier that if the internet was a country, it would be the 7th highest carbon emitter on Earth. So that's pretty significant. Does everyone want to go into smaller rooms, or do we want to just chat here? I'm not sure how comfortable everyone feels about coming off mute, but definitely want it to be an active conversation. So if we want to keep it here, that's fine too. We can kind of put it up here for discussion. I also just don't want it to be too large that people don't feel comfortable.
I personally would love to talk as a large group. I'm a student right now, so I'm kind of interested in
Back on.
talking some of that stuff through with more people.
Okay, cool. Yeah, Akash, are you okay if we kind of stay in one spot?
That's fine.
Trying
Do
to
you want to
check.
use this one or create a
Check
separate
out speaker.
room?
Yeah,
With everybody?
let's keep it here, and
All
then
right.
that way
think it
we
is.
can have direct
Is that going
access.
through the speaker at all?
Sounds great. I'm going to cancel the room assignment then.
Can people
Okay.
in the Zoom call let us know if they can hear me? That's the most important thing.
Yes,
And can you let me know if they reply?
yes, we can hear you. Yes.
Hello, hello. Yes, they can. Great. Thank you. That's our high-tech solution to make sure everyone can hear me. Okay, so for those, I'm just going to talk through the scenarios just quickly for those, just to make sure there's some clarity and people understand what they're about. You probably already dove in, but also for the people on the call as well. So I'm going to be very quick. So how might we apply green ML in our org? So that's thinking about how can we think about machine learning and green machine learning within the org. So if you're doing data science, how could you make your data science greener, right? And you can interpret that however you want. How we might apply green dev practices in our Devops pipelines. So obviously for those that are building software, how can you think about how you could make that greener? I'm not going to give you too many tips because the aim is to really dive in and explore here. How might we adopt the software carbon intensity specification within our organization from a technical perspective? From a business perspective, how might we set up a green center of excellence, which would be driving and advocating for these things within your business? How might we report on green software practices? Super important if people are talking about emission reductions, and that's for a lot of businesses, it's important to look and talk and also report to their shareholders how they're doing that. How might we measure the benefits of green software within a business? So that might be from a carbon perspective, but there might be other aspects to look at. And then from a design perspective, how might we consider green principles in our design, especially when you think about UI design? And there's a lot of things, again, I'm not going to go into it too much, but there are a lot of things you could be thinking about there and aspects you could change there. And then how might we adopt eco-design principles? How can we be designing for a sustainable design practice within a business? Anyway, I'm just going to leave that there. Any questions, please put your hand up and let me know. Yeah. And online, just drop it in the chat as well. Okay, back to it, sorry. Well, sort of what we going to aim to do is people might have their favorites that they want to do. And we are going to be moving to the whiteboards at some stage as well. And there are whiteboards around the room, but we'll let you know about those. But what you are going to do is you're going to vote as a group on one that you're going to focus on. So and you've got 2 minutes to do that.
So is there a question people want to tackle?
Not
Very
something
true.
specific that is popping out at me. I'm still pretty new to the tech space, so I don't know a whole lot about a lot of this.
Yeah, I guess I can, I don't know, maybe start us off. This is actually something that I've been thinking about. So I'm at Indeed, Indeed.com, the job search engine.
Hey.
Hey.
So time's up on that one. If you haven't thought of one, you need to jump on one quickly because we're about to run away, leave you behind. The next thing you're going to do, and I don't think, even though the aim is to do this silently and for 5 minutes think about sort of like, 3 ideas to solve the problem yourselves. I think you're already probably talking about some of these anyway. So, but is to come up with 3 ways that you would, what's the wording here? You would think about solving that problem or approaching the statement starter that you looked at. Come up with 3 ways yourself, 3 ways each. But still feel free to talk amongst yourselves, but it's good if you sort of come up with them 3 each yourselves. I've got 5 minutes to do that, so no rush. And,
So I guess for the second question in tech about how to apply green dev practices in DevOps pipelines, like I'm not sure how to apply that to DevOps specifically, but like one thing that, comes up is like a lot of compute jobs, like compute tasks that are run on like a periodic basis, like typically like on a daily basis. Like that would be a good candidate for like demand shifting, or what they call like carbon intensity shifting. So like just running your jobs at times in the data centers where like renewable energy is high in the mix. I think part of the problem is like a lot of people don't know where their jobs are run, and they don't know like what the mix of electricity is that's available at any given time. So I think that's kind of a big, I guess, roadblock to actually implementing that. But I think, that's something that if people had access to, like they could definitely easily just like schedule the jobs, like their compute jobs or cron jobs to run at like a specific time. Yeah. Yeah, that might be a possibility. Michael said fewer builds, better tests.
Michael had a question on the chat here. Fewer builds is and better testing mechanism can save some energy consumption.
Yeah, I was thinking about better tests and what would be meant by better. It's kind of like would it mean faster tests, I guess? So like less compute. Obviously, there's concerns like with coverage or something. So I'm thinking from like a CI/CD perspective. Maybe fewer environments. That could be a good one.
Yeah. And I imagine probably like the framework that you use, like, this is sort of more involved, but like, you know, if you write your code in like a more efficient language, you know, like Rust is a popular one, you know, that's kind of known to be very efficient. Like that would, I guess that would be more along the better green software practices, but that would also like, you know, reduce the electricity use for a particular job.
How do you determine what languages are more efficient or less efficient?
So there's actually a study that was done that looked at the energy usage of different programming languages and looked at like, you know, based on like memory and CPU usage and like what is like the most efficient. Trying to see if I could find it. I think it was done in 2018, so I don't know how up to date it is, but like I think you can kind of look at, yeah, like basically how much CPU usage and how much memory usage is run by a particular process using, you know, two different languages for the same, you know, for the same like task basically. Let me see if I can actually pull up the study that was done here. Yeah, so this is one study that I looked at, which looked different languages. And they talk about the methodology that they use, but I haven't had time to like do a deep dive into it.
Yeah, this is really cool. I'm definitely going to read this later. Thank you.
Sure. Yeah, that's a possibility too. Oh my gosh, I've been testing too. Cloud resources that have energy source sustainably.
I
Okay.
think, oh, time's up, I guess.
Hey, everybody. So, in the room, I know we're all talking about it, and possibly online as well, because the next step is to share and talk about it within the group. But based on the noise in the room, everyone's definitely having a good conversation, and that's fine. We can break the rules if we're all having fun, and the aim is to be talking about it, right? And so now we're going to get everyone in the room is going to go across to the whiteboards. There's a whiteboard here. There's some markers over there. There's a whiteboard there. The reactor sign over there is a whiteboard. There's a whiteboard in that room. We don't want to go too far, and I don't know how many groups we've got. I think we've got four groups by the looks of things. So you probably could have two on that whiteboard, one on this whiteboard and one on that whiteboard. So if you want to get up and walk over, because you're going to be doing some writing down, and we want to write them down on the whiteboards. Now, online, you should have a virtual whiteboard, but I've heard you're a very large group, so it might be a very complex poster. But is the poster template available for the team online? And if not, people can also start creating their own. And so what you're going to be doing is putting together and writing, what is the problem? What is your big idea that you came up with as a group? And then you're going to sketch it. You're going to draw it. You're going to draw what you think it looks like. Don't worry if you don't know how to draw. Makes it very entertaining. And then what is your action plan? So those 4 things again is, what is the problem? What is the big idea to address that problem? You're going to sketch, you're going to draw it, an action plan. Okay, so you've got 10 minutes to go through this. So we're going to kick off now. So the first thing again is, what is the problem? What is the problem that we're looking at? Start writing on your whiteboards. Yes, first step is figuring out who's got the best handwriting for those in the room. I'll just go talk to the team for those online if they've got any questions. Online, if you have any questions, so chuck them in the chat because I'm checking with the team over there. Thank you.
Yeah, so I guess the problem we're looking at is improving the software carbon intensity of DevOps pipelines. I think that's sums it up.
Through those again. So what is the problem? The big idea. You're going to draw it, and then you're going to write the action plan.
Yeah, so I guess if we're looking at the DevOps pipelines, so it's sort of a question of like, what are you using the pipeline for? So typically a lot of tech companies are using pipelines for testing or deployments. And so depending on what you're doing, I think it will probably impact what you can do to improve the carbon intensity.
I wonder if choosing between infrastructures too, like AWS versus Azure versus in-house.
Right, yeah. Like a lot of people say that cloud is definitely less carbon intensive than using on-premise clusters, but it also just does depend on what you're using. So like AWS doesn't offer a whole lot of insight into like what the carbon intensity of their servers is,
Right.
like on a low level.
We need to get them to step up to that. Which I think Microsoft is starting to work on something like that where you can get them.
Yeah. Yeah, I think Microsoft and Google are definitely ahead of the curve when it comes to providing that kind of information. Yeah. Yeah, I guess I guess in terms of infrastructure, like if you wanted to kind of maximize the the like the efficiency, then you would try to run as much stuff as you can on a server before spinning up more servers. So I guess for like a DevOps pipeline, can you like schedule your jobs so they all kind of run at the same time? So that way you're maximizing the server usage and kind of reducing the uptime for like other servers. Like that might be one way to do it.
And like languages, are there different
Just a quick one, everybody. We've just got a
pipeline?
few minutes left, so you haven't drawn up things or written your action plan. It's a good time to start. I'll give you a couple more minutes, so we'll have 4 minutes to draw everything up, to draw a picture relating to it. And what is your action plan?
Are there different pipeline languages or something like that that
Um,
people can decide to use? like a language, or is it more just where you're going to run it?
yeah, I think so. There's different frameworks for running pipelines, right? So like GitLab has runners, there's Jenkins, there's Circle CI. So I guess there's so the question of like, okay, so what's the framework you're using to run your pipelines? Like how efficient is that framework? Like are there
Right,
trade-offs?
can we get like the language one for the different frameworks?
Right, yeah.
Might be
So
interesting.
so does anyone want to draw something? Because I don't know how to do that.
Well, wonderful. That might be the simplest thing to say, that we'd have like a standard benchmarks by framework or something, a DevOps framework. So there you'd run them all on the same hardware. And you say it's different whether it's test or it's deployment, or but you could you'd figure out some standard thing, and then you try to run the different pipelines on them, and you'd figure out the energy used for each of them and see if there's any difference. It'd be a nice, simple little place to start.
Right. Yeah, and then so like there's pipelines for also like web applications, and then people want to run them on like, is it a mobile app? Is it a desktop app? And so they'll want to run it in different environments, like so there's going to be a cost to that. Like, is there a way to make that more efficient?
Right.
I'm trying to think of what else. Yeah. Yeah, then there's also like the different kinds of tests. So like typically for like web application, you're writing like Selenium tests or some kind of like you know, surface testing or UI testing. So you're going in like pressing all the buttons to see that they all work.
Okay. So we've sort of facilitating online and in the room. If we're all in person, we'd probably go around the room and get everyone to introduce their ideas. I'm not going to be on camera, but I will be on microphone. I'm going to walk around the room. We're going to look at some of the ideas. We've taken some photos, which we will share in the chat to the people online, so they get to see some of the people in the room. But we're just going to go around the room and talk through some of the ideas, and hopefully people can hear. Do we have, just quickly, we've got walking mics. I'm just going to check that they work. Okay. Hi, who's going to speak? Okay, excellent. So introduce your team and introduce what you're working on, and we'll share photos of these with in the chat.
Hello, we're Team Finding Nemo. Our idea is based off of how might we adopt the SCI specification. And basically, we think our best idea is to start by analyzing existing code repositories, then take the specification, calculate what we have going on already existing, and then use that data to either improve new development, or if it's relevant, start improving some of the existing software to make it more carbon efficient.
Awesome. Thank you. Anything else? Anyone want to add?
Yeah, I can add more details. So by analyzing the code, we not only want to analyzing the code in large data centers, but also in decentralized devices, like everyone's phone's iPad, because there's also a carbon cost for that. And for calculating the data with regard to the SCI standard, we might want to think like when's the energy being used, we want to shift it to like in the daylight time when it's greener. And also we want to like maybe put the large data centers into some good places. And also like we want to consider what kind of hardware we're using, because it might reduce the like kind of fixed cost per hour, and also like how much energy is the hardware using. Yeah.
Awesome. Thank you. Okay. Thank you. Round of applause for Finding Nemo. Who's our spokesperson for the next group? Okay. What is your group name?
Hello. Our group name is Wi-Fi. It's very much energy intensive. It will be a major source of carbon emissions based on current rate of AI adoption. We are trying to reduce that. So the big idea is schedule ML jobs based on data lifecycle analysis and the availability of green energy on the grid. So here we.
That's okay. Is the mic still on?
Use some method like active learning, just taking the data that is very much, which can increase the accuracy with very less data and principles, then we can reduce carbon emissions.
Excellent. It's working. Okay, thank you. Thank you, team Wi-Fi info. Okay, the next team, here's your speaker, and introduce your team and then talk to you. Oh, hang on. Okay, it's all good. I'll give you that one.
There we go. So first we kind of mapped out what a normal pipeline might look like. We develop something, we test, we eventually stage and deploy these features, and that's sort of a life cycle of our software. We kind of dug into what test means, the test stage. We're generally looking at what are the qualities. We're testing for qualities, and what are the qualities that matter to us? Does it meet the features that we're being asked to deliver? Is it secure? Does it run fast? We're doing performance testing. We want to introduce a whole new set of qualities around, is it green? And by that, we mean, what is the SCI of this software build we just made?
Yep.
And, ultimately generate a report, something that we can access on a, maybe a per pull request kind of basis. What's the SCI of the software at that moment in time? We might also roll it out even further into all of the sort of like the, looking at what are the green software principles and different techniques for achieving those principles, and generate some kind of like a recommendation engine as well, saying, this is where it is today, but if you do this, 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 and this, we might even make it even further. And then of course, we want to make sure this all runs in the cloud. It's going to be greener. And, a lot of this is, experimenting, right? We have hypotheses. We want to make a change to our software. It might be infrastructure, might be code, might be all sorts of different things. We want to make sure that green report is as kind of pushed as left as possible to shorten that feedback loop, so we can get the results of a test or of an experiment, and then apply the results and change into even further reductions.
Awesome. Thank you very much. Round of applause for the Green DevOps team. And then around the corner here, who's the spokesperson for this team? This is introduce your team and talk to us about what you're looking at.
Yeah, no worries. Hey guys, good morning. This microphone kind of sounds cool over here. We were hoping that if we positioned ourselves strategically in this corner that everyone would forget about us, and I think it worked out pretty well. So I would say our idea is pretty top secret. So we're Sci Heroes for my man Aaron. Good call out for the nickname. What we're proposing is our prompt, I guess, that we started off was how might we measure the benefit of green software? So kind of started off, came up with some ideas for generically how might folks or other companies define what is a benefit, right? So we thought PR, we thought compliance, we thought compete. And then at a certain point, I think we have a pretty diverse group of people with different experiences and knowledge and viewpoints. We thought through, okay, what could be a cost benefit of that? Because I think that oftentimes is something that turns folks away from doing something that is environmentally responsible or what is seen as a good carbon movement, right? So we kind of got talking, and we're thinking that there's an opportunity maybe to reduce a cloud bill through using something like Azure recurring revenue by identifying the benefit of a company's good doings in sustainability and carbon footprint offsetting. So we kind of identified at this point kind of a bottom-up model. The question was, who are we making the hero, right? From a commercial setting, who are we making the hero? Who do we want to make good? So we thought, okay, maybe a VP of infrastructure might come up with a really good idea, and then he's able to go up and pitch it up to a CFO. All good. But now what we're hoping to do is identify ways that the CFO can actually save money and at the same time reward other companies that are making environmentally conscious, good decisions. I think if we had a little bit more than 10 minutes, this could actually be a pretty darn good business idea, but that's kind of where we're at with that. And we're looking into the possibility of coming up with some scientific formula like SCI up top. That was impressive. I don't think we're there yet, but it's some kind of discounted model where, the folks can actually see a reduction in their overall bill by doing the right thing. So that's kind of where we're at in 10 minutes.
Thank you. Okay, we'll get everyone back in the room, back to their chairs. We're actually about to go to a break, actually, aren't we? Can I just check the schedule? Can I? Trying to get a thumbs up if we're going to a break on the schedule, but I can't see the. Oh yeah, sorry, everyone online. So the next one is getting everyone online to share their idea in the chat. Yeah. Actually, let's do that. We're going to go to a break. So everyone go out into the break room because we're going to wrap and go to a break after they share. So we'll go out into the kitchen and then that way we can hear them actually present, which would be awesome. These are fantastic idea. My own voice is, yep, there's me. It is. Okay, now can you hear us? Give us a thumbs up or a nod or a wave. There's a slight nod. I think that's a, yep, okay, awesome. So who from the group's going to share? Mohammed, you're going to be going?
Yeah, I guess I can talk a bit about it.
Go away, shoot.
Yeah, so we talked a bit about software carbon intensity and Devops Pipelines. I don't think we came up with a team name. I think we just talked about it. Essentially, we talked about the different aspects, and one of the aspects we talked about were looking at benchmarking, sort of like looking at different frameworks, looking at different tools, and just sort of benchmarking, see if there's a way to like benchmark different frameworks for their software carbon intensity. So like, for example, for DevOps, there's a bunch of different frameworks you can use. There's like GitLab CI, there's Jenkins, there's Circle CI, and a bunch of others. So there might be one that's kind of more optimal depending on the pipeline that you're trying to build. Like that would, we'd have to set up some kind of baseline. So I shared a paper in the chat about like, measuring energy efficiency across programming languages. And so we could try to do like, a similar kind of methodology to do like energy efficiency for, different DevOps frameworks. So that was kind of like, what we talked about. Yeah. Thanks.
Is anyone else there want to add on the online side?
Okay. So for everybody, wherever they are. So I'm gonna go for a break. So we'll take a break. We're taking a break from 10:45. So we're actually running early. So awesome work. And I think we're reconvening at 11. So see you then.
You guys are in a break. No, leave them so they can hear?
They can hear us. Yeah.
Oh, okay. Oh, so it's 10:30. Okay.
Check, check, test, test. Check, check, mic check, 1, 2, test, test. I jerry rigged it here, just wrapped it around a few times. Just wanted, it's kind of, this is always pointing up at you.
Check, check.
Get you leveled. Yeah.
check, check. Check, check.
Hey, everybody online, we're just about to kick off with the lightning talks. It's going to be getting set up, so people will be up here. It won't be me, it'll be the other presenters that are going to be up here, so they'll be up here very soon.
Okay, 1, 2, 1, 2. One, two, 1, 2. Ooh. 1, 2, 1, 2. Let me come and stand in the right spot. 1, 2, 1, 2, 1, 2, 1, 2.
And which presentation?
I am the reduce energy usage with tiny ml. Number 5. There we go.
That clicker works as well.
Yep, that clicker. Yes, that's the one that's set up. Everyone back? We all back? We all good? Yep, okay. Okay. Cool. Good to go. Right. Hello, everyone. Hello, how are we all doing? We good? Yeah. Yes, come on, everyone do the same. Yes, that's it. Get some energy going on here. Awesome. So up next, we have a selection of quick lightning talks, just to introduce a few fun concepts. And I've got the short straw of going first. So I'm here to give you a quick overview about how you can actually reduce your energy usage with a thing called tiny ml. Got it? Someone they can't hear on Zoom. Are we on Zoom? How are we doing on Zoom? Can we? Still on Zoom? Okay. We're all good? All good. Awesome. So who's heard of ML, machine learning, AI? Obviously. Has anyone heard of tiny ML yet? A few people. Awesome. Cool. So as we know, AI is the future. So AI, we're all about AI. You can't even buy anything these days without it being sprinkled with AI. All your apps and devices and all these things, that is covered in AI. We know AI is the future. Now me, I'm a big Internet of Things person. So if you know me, I'm all about the gadgets and gizmos, and I often have random bits of hardware about my person. And IoT, the Internet of Things, this is a huge growth area for AI. IoT generates a ridiculous amount of data. And so the best way to analyze this data is through AI running in the cloud. So a classic example is what we call predictive maintenance. Got a machine that does something, maybe like a lathe or a CNC mill or some kind of machine. And these machines will naturally vibrate as they do things. Now, if I'm vibrating like this is a good vibration. Yeah, digging out our Beach Boys, whatever. This is good vibrations. We like this. If I start vibrating like this is a bad vibration. And this vibration could mean that one particular part is going to fail. And then this vibration could mean another part's going to fail. So I can monitor my vibrations using an AI model running in the cloud. And then depending on the vibrations I've got, I can say, yes, if my machine's going to break in the next few weeks, this is the part that's going to fail. Let's schedule repairs. It's a classic use case for AI with the Internet of Things. Now, if I'm running this in the cloud, I'm going to be using quite a lot of energy. So my sensor Usually a little tiny device, teeny tiny little device, pulls only a few watts. Got one of those. It's going to be gathering data, sending it over maybe Wi-Fi or a wired network. That's going to then connect through some kind of router, switch, some kind of networking system to the cloud. It's then going to go to the cloud, potentially in a complete different continent. So I'm running this kind of across the world. It's then going to hit a server running in the cloud, potentially running a GPU, graphics processing unit, and that's going to analyze my data. And this is going to be running kind of continuously. And then I'm going to step through that whole kind of networking stack to get my data back. This can use a lot of energy. I mean, just the GPU alone runs at between 250 to 350 watts. So I'm using a lot of energy, and I'm using this continuously, monitoring my piece of machinery. Not very efficient. Now, we can get more efficient using what we call edge-based IoT. You may have heard people like Satya Nadella, CEO of Microsoft, talk about the intelligent cloud and the intelligent edge. The edge is machines running on your premises, but are connected to the cloud and managed by the cloud. So I can train an AI model in the cloud to identify failures in my machinery, run the AI model on an edge device on my network. That cuts down the amount of energy I use, because I'm only sending the data to my network for analysis. And usually the machines you run on the edge are less powerful. So the cloud servers I might use from an AI model, big devices, huge GPUs, edge devices. I mean, here's one, NVIDIA Jetson Nano, runs at about 10 watts. You can power it over USB. So that can cut down my energy usage. I'm going down from 350 watts to 10 watts, plus my data's not going so far. I'm not hitting the cloud. So that's good, but I'm still using a lot of energy. And what if I could actually use less energy? What if my AI model could run so close to my data, there's not even a network hop? What if I could run my AI model on the sensor? And this is where TinyML comes in. So TinyML, as the tiny name suggests, is all about making it small. Taking my huge AI models that run in the cloud with these beefy GPUs and shrinking them down to run on very small bits of hardware. When I say small, I'm talking I can run an AI model on this, which you probably can't even see. Teeny tiny little device, just a little microcontroller, draws less than a watt when it's going at full power. Now I can run an AI model on this. There's a whole lot of tools out there, companies like Edge Impulse, as a classic example, who make these tools to take AI models and run them on microcontrollers. Because it's running on the same microcontroller as the sensor, it's using a lot less energy. At full whack, as I say, it can use maybe a watt of power. So already we're 10 times smaller than my edge device, but it's running on the device. There's no network connectivity, and I can even scale it down from there. So if I was measuring data maybe once a minute, and it took, say, 10 seconds to run the model, for 50 seconds, I don't need to do anything. And then I can actually, on my microcontroller, cut the power back to literally nanowatts. So I only need to draw power when my device is running these tiny ML models, and therefore I can save a huge amount of energy. So I can have a device like this, little tiny device. You know, you can get ones with cameras for running vision AI models, teeny tiny little ones, you know, with microphones and Bluetooth and vibration sensors, accelerometers, and all these type of sensors. I can run AI models on these little devices, drawing less than a watt of power. And then when I need to connect to the cloud, if I detect my vibration pattern means my machine is going to break, I can then fire up the Wi-Fi and connect to the cloud. If I don't need to connect to the cloud, if I don't need to gather data, I can keep the Wi-Fi turned off, saving power. So I could literally run the entire monitoring of my machine for years on a teeny tiny coin cell battery. And there's even advances being done to allow it to gather energy from radio waves around the room. So you can have devices with no power connected to it whatsoever. It's just detecting radio signals from Wi-Fi and TV and all that kind of stuff from the room to power the device. So you end up with this lovely situation where your sensor gathers data and then it just runs the AI model and processes results. We cut a huge amount of energy usage out. There is a question, yes. It's just firmware running on the device. So if you've ever updated your thermostat at home, same kind of idea. So you can actually set up these devices, say they're cloud connected, and push new firmware to the device. So it's up to you how much connectivity you want, how much data you want to gather for retraining your models. But then you can just push more updates to the device. They're connected only when you need it. So totally manageable. So the question was, how to work with updating the models if you retrain a model on these devices and you want to push it again. You don't need an edge-based solution for that. You can do it just by updating the firmware on the device. So there we go, that's TinyML. You would run your machine learning models on the sensor, save an absolute huge amount of energy. If you want to learn more, we've got a great little project, aka.ms/GSF TinyML. And this link will take you to a thing running on a device called Azure Sphere. It's another microcontroller. It runs machine learning models for predictive maintenance and sends the data to the cloud. I'm going to read all about it from a technical perspective. So that's TinyML. If you've got any questions on this, come find me later, or I'm all over the internet at Jim Bob Bennett. Feel free to get in touch, and I'm happy to talk about internet things and TinyML. So there you go. That's how you can save energy with TinyML.
Help.
Do you need me to help keep it on?
Yeah.
So the question was, when you have TinyML, you've got a lot of different sensors gathering data. Do you ever bring the data together to analyze it, or do you just run it on each sensor? It depends. It depends on what situation you're doing. So each sensor will be connected to a microcontroller. So there'll be a little tiny chip that's connected to the sensor, and this chip could be connected to multiple sensors. So if, for example, you were monitoring a combination of vibration plus temperature plus noise, you could have all three sensors on one microcontroller and then have that one model running on that one microcontroller. If you had different sensors running on different microcontrollers and you wanted to gather the data, you could then have an additional microcontroller running the model. So you'd have, say, this one here gathering vibration data, and then you could have this one here gathering temperature data, and they all send a signal over a wire to this one here, which does the actual machine learning model. And you're still running at only a couple of watts, and you don't have kind of big network hops. So yes, you can connect a whole of these sensors together, a whole of microcontrollers together to run these models and keep your energy low. Great question.
Hey, Russ, yeah, we're just talking to the mic. Zoom. Yeah.
It's fine. I can.
Do you still want to stream that data to the cloud for some data store or something, even though the edge device is using it for inference? Is that data important?
Again, it depends. Because IoT devices generate a ridiculous amount of data. We're talking zettabytes of data. And there's been this idea for many years of, we must gather all the data, we must store all the data because one day I might use it. And of course, you think about the energy usage of storing all these zettabytes of data, you think about the physical hard disks, the actual storage devices you've got to use to do this. So it's highly, highly inefficient. Now, a good reason to capture data is to train more models. So you might want to have a setup where maybe if you've got 1,000 machines in a factory, you gather data from maybe 1 or 2 of those machines, and then the rest of them just run. Yeah, because it's 99.999% of the time it could be useless data. If your machine's got a lifespan of 30 years, you know that probably for the first 29 years, it's going to be absolutely fine. So all that data is just useless. It's fine, it's fine, it's fine. Normally what you might do is have a thing where when it's kind of getting close, the model says, oh, there's like a 50% chance there's a failure, then you might start streaming the data to the cloud for more detailed analytics. But generally, it's most of the data you gather is just a waste of time, so you wouldn't collect it.
Are they removed from these databases later? I mean,
Share with Zoom.
What, sorry? Yeah. I mean, some companies are just leaving the data sitting there. They've gathered this data and they're just leaving it there because they don't know what to do with it. One day we might use it. But yeah, there's definitely a lot of wasted data out there. And then you have with companies who just go bust and their data just gets lost. So I haven't heard of anyone actually doing big cleanups, but I imagine there's probably a lot of companies who are looking at their cloud bills saying, why are we spending $1 million a year to store data from 10 years ago that we don't care about from a machine that doesn't even exist anymore? So yeah, I imagine there's probably quite a lot who are doing that level of cleanup. But yeah, the amount of data is just ridiculous with IoT. So anything like this that can reduce the amount of data you store is going to be a huge benefit. Cool. Any other questions? Any questions from the chat? Yep, microphone coming your way.
Two questions. So what biggest business scenario for the tiny ML application? And the second is, I think there's a lot of startups like doing Fed ML, like federated ML, like doing the same thing. What do you think is the Microsoft's advantage for that?
Okay, I'll answer the second question first. Microsoft doesn't have a TinyML solution. So I normally, when I'm doing TinyML, there's a company called Edge Impulse, which is one of our startups, and they have a fantastic online solution for building TinyML models. So Edge Impulse are my heroes here. They have a great tool. They can just gather data from microcontrollers and build these models for you. And the first question was the kind of the business model for TinyML, yeah? What can you use it for?
Yeah.
So because you're running on these very, very small devices, these devices are cheap. You can literally buy these devices for less than $1. So if you've got a factory with 1,000 machines in it, you want to just cover it in sensors. And so industrial Internet of Things is one of the biggest use cases because you'd want to just cover your machines in sensors to detect things. Avionics, if you've got a plane, you've got a lot of data on the plane. Why not run the machine learning models actually on the devices connected to the engine, to the rudder, to the wing, the aerofoils, all those different parts of the plane? NASA are doing a lot of work because you've got big rockets. You've got a lot of data. Rather than stream millions and millions of bits of data from a rocket to the control center, you want to make decisions on the device. Partly just streaming that data takes a huge amount of time. So if you want to gather more data because you've got more moving parts, you can't get that data. Just literally, you can't send that over a radio wave from a rocket in time. So you can kind of use these devices to monitor it. You're up in space. You're on a mission to Mars. It takes 30 seconds for the data to come from Mars. On a good day, well, if you can run machine learning models actually on your Mars rover, again, you can process the data much quicker than you can get it back to Earth. So huge amount of use cases, mainly around industrial IoT.
Gosh, yeah, thank you so much.
Thank you.
Any other questions? Mic check, am I good? All right. Brilliant, Jim. So hello, everyone. My name is Tammy Mclaughlin. I work for Microsoft. I am a CSAM dev. So I am a customer success account manager, and I work with customers at Microsoft or other companies. So I wanted to talk to you today about my use case. So it's the WTF SCI. So I'm probably going to get scolded a little bit, but WTF stands for Wonderful Tiny Farm. So, I actually had it in here, but it didn't quite make it into the final version. I had an EPA chart where it broke down carbon emissions by sector. And the two biggest sectors were agriculture and electricity, right? So in my life's work, I focus on both those things. So I have a farm, 10 acres out in Chelsea, and it's called the Wonderful Tiny Farm. And my husband, for the record, came up with the name, but I love it. And so my use case is centered around my wonderful tiny farm and insights to my farm. So we'll go into a little bit of detail, and I'll focus on the use case itself, although I'll throw some other stuff in as well. Again, you've already seen this. This is the SCI calculation that Vaughn went through a little bit earlier. So I don't have to explain what all that means. So every year Microsoft does a hackathon, and last year I hacked for sustainability, right? So here we are with the team. I had folks from New Zealand and Africa and California, of course, myself in Michigan and Georgia. So folks came together. It was great. I got a little snapshot. We created these running .NET Core, an application that allowed me to collect environmental data about my farm. So I'm collecting, you can see the JSON data. I'm collecting information about the soil moisture, sunlight, temperature, humidity, etc. So that was part one, participating in the hack. And then always for me in the back of my mind was I wanted to go back and apply the SCI score to this, because for me it was a real simple solution and it would be a good first step into SCI for me. So the first thing I did was buy a power meter. So I have the solution is a little Raspberry Pi, and I bought a power meter and I plugged it in and I started measuring the amount of electricity that the Raspberry Pi was consuming over a period of days. In my area, the cost of electricity is 98 cents per kilowatt hour. And over 10 days worth of time, or basically by day, the amount of kilowatts per hour was 0.003. So I talked a little bit about the solution already, but just to kind of recap, a Raspberry Pi with some sensors, and it is outside in my farm. So, and the application, it's running headless. It's a .NET Core console app. So now the meat of the whole thing is the SCI calculation. So again, the energy consumption was 0.003 kilowatts per hour for every day. So what we did was, once I had that number using my little power meter, we times that by 365 days. So my per R is actually per year. So that's what the calculation is based off of. So so part of the SCI calculation is understanding the marginal location carbon, which is sometimes very hard to calculate, right? So the quest to find that data, the GFS has a very great partner in Watt Time. So if you haven't been out to their website, you can go out there and look them up. But I contacted Henry at Watt Time and said, hey, help me figure out the marginal location of energy for my area, because I'm running the Raspberry Pi on my farm. And so I needed that information. And he came back with 0.713 kilograms per kilowatt hours. So that's the marginal part of the calculation. And then, so that would be the I. And then of course, what's left is the embodied carbon of the unit itself, the little Raspberry Pi. And so that again was very difficult to figure out. So I went out to Raspberry Pi and I said, I contacted them, some forums, I contacted them directly and I said, hey, do you guys know what the embedded carbon is for your little Raspberry Pis? And they came back and they said, we don't know. So I'm like, okay, great. But they also said they were going to go back and work on it. So for me, that was a bonus. Not only I'm bringing something to them, understanding what SCI is and how do we get that data from you in the future. So in lieu of that data, I did find another study which said for a mobile phone, somebody went about calculating the embedded carbon in the phone, and they came back with 55 kilograms. And what we did was we divided that by 3 years, because usually a smartphone or some sort of device is only, the lifespan is 3 years. So we took that information. So the 55 kilogram per 3 year is where we got that information. And that's actually for a smartphone. So at the end of the day, so doing the math of everything that I calculated, and by the way, this did take a while. right? So even having a Raspberry Pi as an edge device, you know, that the edges around the solution was the Raspberry Pi itself and the sensors. It ended up being 19. So 19 was my SCI score. And for 1 year of running that solution, which I think so far out of all of the use cases, I'm not, you know, to this date, 19 is still the lowest SCI score that has been done. So, and that's 19 is the carbon equivalent, the CO2 carbon equivalent output of the score. All right, well, that's pretty much it. Any questions? Yes. That is a really great question. Sure, yeah. That's a really great question. Because the farm is outside and we follow a regenerative farming techniques with the way that we grow things. So there are things that we do with the soil to keep the carbon, so sequester more carbon in the ground. And I haven't really looked at how to make it even more sustainable than that because it's outside. What I am interested in though is trying to reduce that score of the software running on the Raspberry Pi and how I might reduce that score overall. That's a really great question. Thank you. Oh, yay, few more.
So just looking at the score, the embodied emissions seem to be like significantly higher, like to the point where, you know, electricity doesn't even matter, right? Is this just because it is a Raspberry Pi, or is this actually something that you've seen repeat across, you know, like other use cases based on what you've seen in GSF as well?
So I think that as far as data go, that's been the hardest to collect right now, right? And a part of the foundation and what we're trying to do is find ways to make that public, that information aware so that we can start to build on that, right? So looking at the embedded party carbon in devices is really critical for moving forward. We're doing that with the same with, you know, laptops and the work that Vaughn is doing to try to expose that data and move it forward. But yeah, you're right. And it does seem, because it was the closest number that I could get, it's the one that I took. But because it's a Raspberry Pi and the footprint is smaller, I'm sure that the embedded carbon in the hardware is much smaller than probably I can report right now.
Yeah, I think one of the things to think about changes from the device to device, and then you have
Right.
considerations. For example, if you're deploying into cloud, you know that's already sitting there. You're using some of the capacity of that. You need to be mindful of it, but you're using a small part of something that's quite large. So if something's consuming a lot of energy, you'll probably find that the energy calculation becomes super important. But embodied carbon generally becomes really important in small devices because the energy is so small, but you might deploy thousands of them. And then all of a
Right.
sudden the maths, you might have efficiency maths and the energy efficiency maths, but then that carbon efficiency conversation, which is sort of when we said the overarching principle is thinking about carbon efficiency. You don't want to go, oh, this is super energy efficient, but then all of a sudden you're just shifting that carbon to be in 1,000 devices. So it doesn't mean don't do it. You just got to, it's part of the calculation.
Right. And to that point too, you know, if I wanted to scale up my farm and produce, you know, put more of these, then my SCI goes up. But going back to your point earlier about how I could use that data on my farm, one of them is the soil moisture, right? That one of the sensors is being collected. So I can start to make intelligent decisions about when to water and when my farm needs water, instead of me scheduling it or figuring it out. So that's one of the ways that I see that this insights project is going to help on the farm overall. Yep.
So how did you get the 0.713 kilograms per kilowatt hour?
So that was through my friend Henry at Watt Time. So I actually, because I had that connection, you can go to Watt Time and it does give you an emission score, but Henry was able to give me an exact calculation based on my location. So it was really through the GSF, I met Henry and I was able to get that. And last question?
Yeah, just on that, the other thing is the Carbon Aware SDK's core focus is to help you get that number through, sort of abstract away all the different ways to get it and give you a standardized way to get that number.
I might have missed something here, but is it all manual calculation you from the adapter that is being plugged into the socket? The energy thing aspect of it.
Yeah, the power meter that I purchased. Yep. The only thing I had plugged into it was the Raspberry Pi. So it was, and I had put in the price per kilowatt hour. And so I just monitored the use, and my little power meter actually came back and told me, how much energy I was using and then how much it was costing me as well.
Got it. Then it was not synced automatically to the cloud and nothing like that.
No, the edges of this is just the Raspberry Pi and nothing outside of it.
Got it. And if we use a solar panel in the farm to power that Raspberry Pi, will I be zero here?
Yeah, that's great. Yeah, absolutely. And that'll be a next phase to this, is starting to get the solar panels to be able to power those. And this was based off a project called Farm Beats, right?
Yeah.
Some of you might be familiar, right? What we did was we took those concepts, but we just scaled it down because we had a very quick, 3 days for the hackathon.
Got it.
Yeah.
But then if you're installing the solar panel, are we doing a life cycle embodied emission on the solar panel and then considering that it is powering this device for 10 years? So add that to the I, there's nothing like that, right?
Yeah, no,
Okay.
not yet.
Yeah. So, I mean, you've got to consider it, right? It's going to be
Yeah.
creating carbon. So it's all a balancing act, right? Like where do you focus? So.
And it's ever evolving, but right now we have a number, right? I have a number, and I can go about ways to reduce that number, including solar panels, etc.
Got it. Thank you.
All right. Great. Thanks. All right. I won't touch anything because I broke it last time, I think.
All right, and thank you. I'm the last talk between you and more networking. So my goal is to keep this in an interactive format. And thank you, Courtney, for keeping people in the Zoom chat, and you too, Fiona. So okay, yeah, I'll speak a little louder. Hopefully not enough to hurt your ears. I want to take a moment and just have you kind of ground you in where we are. I'd like to take a moment to look around the room at the others who have come here, you've had a chance to meet today. And because I like to do things a little differently, I'd like to, if you'd like to, just close your eyes for a moment. But I want to invite you to notice your body. Notice your feet on the ground. Notice the sense of the chair you're sitting in, or the floor you're standing on. And as you sit or stand, I'd invite you to recognize your ancestors that without which you would not be here today. A chance to think about that lineage that through human history has never been easy. But because of your ancestors, somehow you've made it here today to sit in this room in conversation with these people. And I want you to remember also that essence of what's calling you on, and that remembrance that is always available to you. And as you think about what has brought you here today and what's calling you on, I'm going to share a few stories from history, a few lessons that you might be able to carry with you as you go out and do your great work in the world. Can I get a forward click? I can use this. I can use this. Yeah. Yeah. You can do it the old-fashioned way here, analog and all. Not getting me a slide function. There we go. Okay, has everyone heard this quote before from Margaret Mead? Never doubt that a small group of thoughtful, concerned citizens can change the world. Indeed, it is the only thing that ever has. And I think it reminds me that even in times that we're in, we live in interesting times, it's easy to feel stuck in systems that are broken. So as one of my mentors used to say, it's easier to create what you imagine than to change what is. And so I want to tell a few stories from history. Does anyone recognize any of these? Raise your hand if you do. Yeah, which ones? Peak oil. This is a different peak oil. I'm gonna start at the left, the natural step. Okay. This is I have a little bit of history, so I brought some paper just to make sure I get it all right. This actually started in 1989, and the natural step was started by a group of scientists around the world who wanted to figure out what are the system conditions of sustainability. And so they worked with hundreds of leading scientists around the world to come up with one document that captured and agreed upon systems conditions for sustainability. And there's really 4 system conditions in the natural step. The first one's super simple, but they're done in very scientific terms. So it's about not systematically increasing the concentration of substances in the Earth's crust going into the atmosphere. So the idea is don't pump it out of the ground and put it in the air. Number 2 is concentrations of substances produced by society, not systematically increasing. Don't pollute, right? The third one, degradation by physical means. This is, in that urban planning context, right? Is don't pave paradise, right? Because then you reduce the ecosystem services of the trees and the ground, the soil that's there. And the fourth one is actually interesting. It's about that human needs are met worldwide. And as we look at what we have ahead of us to solve, the difficult problems ahead of us with climate change and the impact on people and animals, this is an important one to consider. We've talked a lot about carbon today, but we also need to think beyond and what are the problems we're using the software to solve. So story number 2, the Hypercar. Okay, this was, I think the one lesson I wanted to say about the natural step that I didn't include was, first of all, they got consensus among scientists to come up with certain language, similar to the carbon math we're getting, consensus on today. The other thing is they brought it to the king and queen of Sweden. And because they have a monarchy, the king could decree that every school child in Sweden was going to learn the natural step as part of their elementary school education. So this became part of the culture, part of the culture people are growing into. So it may not be that you've ever heard of this today, but it has amazing impact, and it continues, the organization is based in Sweden, continues to have pretty significant impact. in the world. Hypercar, has anyone ever heard of Amory Lovins at the Rocky Mountain Institute? You know that name? Brilliant human being. I recommend following his work and the Rocky Mountain Institute's work. He designed this car and started in 1991, a vehicle that was up to 65% lighter than the average car, with 92% less iron and steel, under 20 moving parts, powered by fuel cells, and generating enough fuel when it's parked that you could power your place of work or your home, right? So, of course, in the traditions of the big car manufacturers and innovation and stifling innovation, what do you think would have happened if he had sold it to one of the big car manufacturers? Yeah, they would have shut it down. So what did he do instead? He published it in the public domain. He put it on the internet, the plans, so that instead of allowing one of the big car companies to buy it and stifle it and shut it off, right? Everybody had to fight over what to make. And clearly he was, 30 years early in terms of his belief in where fuel cells would be today. But, Toyota has done a lot of good work in that direction. There's a lot of work that's coming. We're using batteries to get there. But that energy generation is definitely still there. So I think the lessons are keep your visions big and publish it on the internet. Okay. And the third one is following in Tammy's footstep there. This is actually, guess what year that was that we got to peak sperm whale oil production in this country? What year do you think it was? 1846. 1846. So what was sperm whale oil used for back in the day? Lamps, lanterns. So there was enough demand for this oil during the 18th and 19th centuries that it almost drove the whales to extinction. And what saved us from what technical invention, what transition saved us from sperm whale oil extinction or sperm whale extinction? It was the light bulb. Before the light bulb, it was kerosene lantern. So it was kerosene lanterns and then the electric light bulb, right? And you'll still see kerosene lamps being used, not a particularly green solution, right? But who do you think lost the most money when they went from this to kerosene to a light bulb? The people financing the whale hunting expeditions, because they were super expensive, they were super costly to life and limb, and not a lot of people came back from some of those, especially towards the end of the hunting. So it's good to think about the change happens over time, and part of our job is to change systems, right? There's a couple of things that I think are important when we're thinking about big systemic change. How many of you have dealt with large organizational inertia that you're trying to make change within? Raise your hand if you've kind of had that experience. Yeah? How many of you are kind of working as an entrepreneur to kind of create your own thing and trying to drive change in that way? Yeah? A bunch of people on both sides. So if you think about it, the path is long and there can be a lot of entrenched ways to move. But I think about leverage points in the system being one of my first places to go. Real conversations like the ones we're having today to land people in the same place. And third, the practice of new behaviors. And we'll talk about that a little bit more, because people will change their values to match their behaviors before they change their behaviors to match their values. So this is kind of from a marketing person's point of view about amplifying your impact in a noisy world. These are really my first 4 tips, which the first one is about you do you, right? Each of you have your unique, not that many people are a customer success account manager and a regenerative farmer all in one. And what a great story, right? It's hard to imagine that there's not another Tammy anywhere else in the world, right? And I think the same for every one of you. Persistence. I think about that with Amory Lovin and his work in the Rocky Mountain Institute. He has just quietly gone about doing his work. And some of his innovations have been enormously successful and been commercialized. Some of them are just still ideas on a napkin pad. But him doing his work over time, he looks up and all of a sudden there's a bunch of amazing people doing similar work around the world because he's been walking that path. I think the community, like what the people you're here with today, is, I think for me, the other big thing to remember. in that it's a lonely path sometimes when you're innovating, but finding that shared support can bring you in a place to go a lot further. And then positioning and telling your story, it really is a combination, all of those. It's who you are, what your work is, who your community is that can inform your positioning. And in our traditional positioning work in marketing, we do a lot of that, what's your competitive moat, what's your unique position, but it's a little bit different. I think there's a lot of room for telling that story a little bit differently. That's kind of what I'm up to in a lot of the work I do, both with Microsoft and some nonprofits I work for. And I'm going to leave you with one lesson from behavioral psychology. Anybody ever look at those little placards under the towel rack and wonder if they actually make a difference? Yeah? No, just me. Me and a couple of researchers in Luxembourg who went and did a study. So they changed the signs to see if they made a difference on people's behavior. And can anyone guess what changes in the messaging actually changed what people did? Any ideas? Fun? No ideas? Okay. So all of the signs said, generally the environmental benefits of towel reuse. Then one set of signs said 75% of guests in this hotel reuse their towels at least once during their stay. And the other sign said 75% of guests in this room reuse their towels during their stay. And if it was in the hotel, it was 1.6 towels per day. If it was in your room, which is a little creepy, right? But it said 1 towel per day. So 40% reduction in towel expenditure if they resonated that other person is like me. So when you're going out to get people to change their behaviors, the key lessons are make it easy, make it fun, and make it clear that every other people like you are doing it too, and you don't want to miss out. That's my thing to add today.
I absolutely loved your talk. I feel like, could you give an example for maybe your own career or the nonprofits you did where you were able to take these practices and personally amplify your impact?
Amplify my impact within the practices?
Yes.
Yeah, it's funny because I'm like, well, which ones can I talk about? I'll tell you one that's actually it's really open for me right now. There's a great nonprofit called planetarycare.org. They are focused on regenerative ag. And their goal is to accelerate the transition from traditional ag to regenerative ag. And so I'm supporting them in the messaging and positioning work, kind of an interim CMO type of role. And what's been very interesting is we've gone through a beautiful process with, it's called the U Lab with MIT and Otto Scharmer's work in presencing. And so the idea is to find the coherence in the system. So I think one of the things for me, I'll tell you a little bit about the career story for me is that I came from sustainability into tech, and then I also took about 7 years off to ski full time and compete in skiing and teach skiing around the world. And then I ended up at Microsoft as a product manager some years ago. And so since I've left, I kind of came back to the desire to focus my work in sustainability and social impact. And it has taken a little while, but there is no shortage of work now. But 7 years ago when I hung my shingle, even Lucas Joppa asked me over lunch, before he was in his role, he said, can you make a living doing that, right? So, it's taken some of that. I'm not sure yet, but I'll find out. And I've also done some work that is not just in sustainability and social impact in order to move my work forward. So since I'm not a super techie person, but I've been in tech long enough to speak the language, my value add is around messaging strategy and facilitation. And I know that, those are my superpowers, knowing my authenticity. And so I can add that to the room where I'm not going to be the person that's going to tell you how to actually implement the solution the way that Vaughn might. Go ahead.
Mike, I've got the mic, so it's good. It's my question.
Sure.
Can you please explain to the people in the room who Lucas is? Because a lot of people would know who he is.
He's the Chief Sustainability Officer for Microsoft.
Yeah, and he was asking you whether you could make a living out of it.
Right.
Yeah.
Yeah.
All right. And it's changed for him as well, right?
Right. And I actually encouraged him to write his paper to get his job at the beginning of, because he was a conservation scientist in Microsoft Research, right? And there's impact to be made, if you can keep your vision at that level of that long journey, and also decide what you want to be devoted to, even when you're not being paid for it. That's part of my, I guess, advice to the room. Go ahead, please.
So, yeah, I love the way you talked about, the historical context, right? And I'm trying to find that point of leverage right now. So, I'm trying to build a company, like in sustainability, right? And like every time I go and talk to someone, the first thought that they say is, "Oh, it's a noble gesture, but it's not a business priority," right? What do you tell people like that? Like because I mean, it's a hard, like uphill battle, right? So just curious.
Yeah. So, so I think the stories are good. Amory Levins is also a good person for you to follow because he's been trying to get us to peak, petroleum oil for a while, right? And so his way of going about it is actually making friends with all the execs of the oil companies and trying to find them new jobs that are not dependent on an extractive industry, right? So speaking of leverage points, he made buddies. He's actually on the board of like the oil decision makers because they invite in this, Einstein-like guy because he like is friendly, he's supportive, he knows they need a new job, and he knows they need a business model that's not extractive, right? So we're going to create these business models together, the business models that allow us to all live in a thriving planet, hopefully our grandchildren as well, right? We need you to think through those business models, right? So I would just take it as a challenge, right? It doesn't exist today, but there's a lot of smart people in the room thinking about business models, and I'm happy to connect with you and share other people that are working on it with you as well. Yeah. Go ahead, Maya. Yeah.
I think as somebody else who works in like pioneering sustainability, I work more with like governmental stuff, but like working in such a large corporation where things can be so slow, like how do you manage burnout when you're like fighting for these things within a corporation?
Yeah. So great question. And for the folks could hear that because people hear that on the Zoom call. So, so the question really is about how do you actually fight burnout? But I think the other question that I'm hearing is how do you get through the inertia, the stuck energy, right? I think it's through that community of friends and through that entrepreneurship. So if you look at Gifford Pinchot and Libba Pinchot's work, they were the founders of the Graduate School of Business that is sustainability focused in Bainbridge Island, or started there. So they have worked early on with the same idea of organizational change. So they'd be good people to like look into their work. I think for me personally, it's finding the people that care and building that kind of alliance. I think that the people that even the foundation of the Green Software Foundation came from a bunch of committed people getting in a room saying, we're frustrated, we want to solve this problem, people don't get it, and people aren't funding it, and I can't get my manager to back it. But we're going to go build this together in our night hours, and then we're going to bring it back into the and have impact where we can. Did that answer your question? Okay, thank you.
So something just to that point is, I find that I get a little bit burnt out around, especially because a lot of it's extracurricular, right? It's all this finding the time to do it. But I always find if I go and talk, because you're passionate about something when you go and talk to somebody else about it, and you come out of that conversation always with more energy. And I think you got to find the things that give you energy in the space versus consuming your energy. So beating your head against a corporate wall, you might keep doing that, but don't put all your energy into that. Go find things that also will give you energy to go and beat your head against the corporate wall, right? Cool, thank you. Round of applause. Oh, it's gone flat. Okay. So we sort of we lost power to the laptop in the room that was presenting. And so let's see how we go. bear with us for a couple of minutes while we get this all reconnected. Back on. All right, so we are going to sort of break out into discussion and things like that after this, but they're just going to do a couple of things to wrap up. And a little bit of housekeeping as we go out the door. Yeah, no problem. I need to reshare on Zoom as well, I guess. Excellent. We need to join on Zoom as well. We'll be connected shortly. Sorry, everybody. Yeah, got it. Just never it's open. Okay. Hope everyone can hear me on the call. You should be able to hear me. Okay, now we've fixed that. We've got power back in the laptop, which is important. Thank you. Oh, it's not still in sharing. Hang on. There. Yep, cool. Jumping through hoops. Oh, okay. Okay. I think there's only 2 people in the room that weren't involved in fixing that problem. So everyone's already seen the slides. Thank you, everybody. It's great to have everyone here. To me, it's amazing thinking about just the where we've come from a year ago in the GSF, and now just having people here. I mean, if you want to get involved, always feel free to reach out to us. Just go back to slides. There's 2 closing ceremonies. Tammy's actually hosting one of those from memory, Tammy. So make sure you visit summit.greensoftware.foundation to find out more about that and sort of join and participate in those. And they'll be held in different time zones. So for those of you that might be joining as well, wondering what time zones are in, but go to summit.greensoftware.foundation. You'll find any information there. How to stay involved. So join a working group or a project. We have 4 working groups. We have projects. We have the Carbon Aware SDK. Shameless plug for myself, but we have a lot of other projects as well. And no matter what your role, your background or skills, there's a role that you can play in all of those projects, right? Maybe you're not a coder, but you like writing documents, or you like writing blog posts or editorial content or anything like that. Or maybe you're interested in helping out with translation. There's so many things that we need, and they're all critical, right? Because if we can't share this with the world, we only impact those that speak English, then we sort of aren't really making the impact that we want to be. So even things like translation are super important to the success of the project. Attend another event. We are going to be running other events. Closing ceremony is a good one, but we also, meetups and things like that are kicking off around the world. And so if you want to know how you can get involved with those, again, reach out to us. Get your organization and network involved. Even sort of, start talking to your organization about maybe joining the GSF, or even just talking to them about the GSF. We were talking before about being your head against the corporate wall. Then maybe joining might be the big step, but maybe awareness is the first step. So think about how you can, think big, but think about some immediate steps of how you can start working with your organization or your network, right? We all have people that work across the organizations we're part of and other organizations. How can we start to make them aware and get involved? And support sustainable development. Whether you're part of a team, whether you're leading teams, whether you're working with teams, maybe you're a project manager and you're working with teams that are saying, hey, they want to think about things from a sustainability perspective. How do you build that into your day-to-day? How do you build that buffer so people can spend time doing this? Because it is important. That's why we're all here today, because we think it's important. So just think about that. To learn more, all the information is on the greensoftware.foundation. And if you want to sort of, what events are upcoming, you can have a look at meetup.com/pro/GSF, and that's where sort of the meetups are going to start taking place. Maybe you want to start participating in those and supporting those, or just attending those. Feel free. If you want to, find out anything else about today, feel free to contact myself or put the questions in the channel on the Zoom call. But with that, I just want to say thank you very much. We've got some networking here. Thank you to everybody that's attended virtually for your attention. Thanks to everybody who presented today. Thanks for everyone that helped with setting up a laptop, which is everyone in the room, plus the team that's supporting here at the reactor. And a big thanks to Microsoft for hosting today. So thank you very much. Without further ado, I'll let you all go and network. Thank you again.